I would like to welcome you all to the lecture series of Analog Electronics Lab. In this session, I'm going to discuss most important Viva question for the first experiment called Design and Setup BJT Common Emitter Voltage Amplifier with and without feedback and determine the gain bandwidth product input and output impedances. I have already done the demonstration. You can watch the playlist. You can watch the particular lecture in the playlist and you will understand how to do the experiment. However, Viva is also a very important part of the examination. Let us see what are the most probable questions you can expect for Viva boards. Moving on to the discussion, first question is, what is the purpose of using feedback in the voltage amplifier circuit? You should understand what is a feedback, why it is required. So if I use the feedback, definitely I can improve the amplifier gain. Voltage gain means output voltage by input voltage. Also, I can improve the bandwidth and minimize the distortion. That is another plus point, and adjust the input and output impedances for the better impedance matching. So like you might have studied about the maximum power transfer theorem. So trying to match the input and output impedance, that is another peculiarity. So this is very important question. You can expect a similar kind of questions and be discussing further. So make a note of this. Second one is explain the basic principle of operation of BJT common emitter amplifier. You might have heard about common base, common emitter, common collector configuration. We use common emitter configuration here. So the peculiarity of common emitter configuration, if I talk about the common emitter configuration, we can see here the input signal is applied to the base emitter junction and output will be taken from the collector emitter junction. You might have studied the basic electronics, correct? So the transistor operate in the active region. There are three regions, cutoff region, active region, saturation region. If you go for this common emitter configuration, the BJT operates in the active region. The peculiarity is the changes in the base current control the much larger collector current. Okay, the control strategy you have to remember. And also it leads the amplification of the input signal. Okay, so that is what exactly focused on this particular question. Let's move on to another question. So kindly make a note of this. How does negative feedback affect the performance of voltage amplifier? If you go for negative feedback, it reduces the overall gain of the amplifier. On the opposite side, the stability will be improved. Apart from that, there's a reduction in the distortion. These are the plus point of negative feedback. What is the gain bandwidth product? GBW, short form of an amplifier. So it is a constant actually, and it determines how the gain of the amplifier decreases whenever the frequency increases. You might have heard about the one graph also. Graph also you might have studied. You might have studied the frequency response. Okay, the gain bandwidth product represents the product of the gain and the bandwidth of the amplifier. So that's a speciality of gain bandwidth, the product of gain bandwidth. Whenever you are doing the design, you will be considering the gain and bandwidth. That's the most important parameter. Question number 5, how do you calculate the input and output impedance of the BJT common emitter amplifier? The input impedance is typically determined by a resistance connected to the base of the transistor. Where if I talk about the output impedance is computed by using a resistor which is connected at the collector side. Okay, that's a way how you are going to compute the input and output impedance of the BJT CE amplifier, common emitter amplifier. What are the advantages and disadvantages of using the BJT transistor in the amplifier circuit compared to MOSFET transistor? So you might have known different type of transistor, signal transistor like BJT and MOSFET. Okay, BJT is a current control device, where MOSFET is a voltage control device. BJT transistors are typically offer high gain and lower noise compared to MOSFET. That's a plus point. But the power dissipation is very high in case of BJT, power BJT. So switching losses will be very much high in case of BJT. MOSFET on the opposite hand, it has high input impedance and more suitable for high frequency application. It shows high switching frequency as well. That's another specialty. Regarding the stability wise, better go for MOSFET. Even it is having very less switching losses. That's a plus point. So that efficiency will be enhanced. How does the temperature affect the performance of BJT amplifier? So temperature has the major role. You might have heard about the thermal runaway. So the temperature can affect the characteristics of BJT transistor, causing the variation, the gain. Definitely gain is getting varied, even bandwidth. Apart from that, other type of parameters. So thermal runaway, that will destruct the entire BJT. That you might have heard about the thermal runaway. Question number 8, explain the concept of Miller capacitance and its effect on amplifier performance. Please note that this is one of the important questions for the theory also. Okay, so derivation you might have studied, Miller theory you might have studied. The Miller capacitance refers to the effective capacitance between the input and output of the transistor amplifier due to the amplification of input capacitance by the transistor's gain. Okay, it is related to the effective capacitance between the input and the output terminal of the transistor amplifier. It can reduce the bandwidth and stability of the amplifier if it is not properly compensated. We should require some kind of compensatory circuit. If you are not providing the compensatory circuit, definitely the stability and bandwidth will come down. What are the methods of improving the bandwidth of a BJT common emitter amplifier? So there are different methods available. So bandwidth can be enhanced by reducing the coupling, then bypass capacitors and minimizing the Miller capacitance, and they use the high frequency transistors. And also there are different type of technique like a neutralization. If you follow this technique, obviously you can improve the bandwidth of BJT common emitter amplifier. I feel that this question you can expect in the Viva question. Most of the professors will be focusing on these kind of questions especially. Last question, how did you measure the gain bandwidth product experimentally? So what is the for procedure? The gain bandwidth product can be measured by plotting the gain of the amplifier against frequency. Better you can go for anti-log graph, semi-log graph, and it determine the frequency at which the gain drops to unity. Okay, that you can find out from the graph itself. This frequency is multiplied by the unity gain value, which gives the gain bandwidth product. You can note on this particular point. So plotting of the particular graph from the graphical method you can adopt. Using the graph only you can adopt. Okay, so find out when the gain that is directly moving on to 1. Okay, so these are the important questions. Let me know if you have any queries before going to the Viva question. You can watch this particular video. You can have a note of this. Also, I'll be in the coming session. I'm going to discuss the second experiment, different type of oscillators. So I'll be stay tuned. Happy learning. All the very best for your practical examination.